Radiation is one of the biggest dangers facing our space crews. In fact, exposure to it is such a risk that officially, the U.S. Occupational Safety and Health Administration lists all astronauts as radiation workers. This designation means that over the course of their career, an astronaut can only receive the same levels of radiation as any other nuclear worker. Of course, since radiation does not stay constant in space, monitoring the fluctuating levels can be challenging. Since the end of the Apollo program, researchers have been able to keep close tabs on crew exposures due to the fact that none of our recent crews have traveled outside of the protection of the Earth's magnetosphere. But what will happen when crews begin to travel on longer missions away from the protection of the Earth? To help answer that question, I spoke with Mary Van Balen at NASA Johnson Space Center.
As NASA's radiation health officer, I use the information that's provided from the dosimeters that the astronauts wear in space to assess their radiation exposure. I would think most people are familiar with a film badge that's used in an X-ray suite when they go to get X-rays done. We use similar passive monitors. We use different materials because the radiation environment in space is different, but it's the same basic idea. The crew member wears this badge or this dosimeter and during the time of their space flight, and when they return to Earth, we process that dosimeter, which gives us an estimate of the astronaut's radiation dose in flight, and then we use that to compare to the radiation limits.
How do you limit the amount of radiation an astronaut's exposed to?
NASA starts off with using scientific evidence to know how much the human body can be exposed to without seeing any clinical damage. So short-term limits or career limits are used. Short-term limits are designed so that the astronaut wouldn't get too much radiation to cause one of the acute radiation syndromes. We also have career limits where we try to limit the astronaut to an increase of 3% of fatal cancer. Radiation exposures have a risk associated with them, and that risk that's most fundamental to NASA is an increase in cancer. And so we try to limit our astronaut crews to no more than 3%. It's kind of an interesting thing because the increased risk of cancer is based on the age at which you first received that exposure. So younger individuals are more susceptible or have an increased risk than older individuals. There's also a gender dependence on that, and so females are considered to be at higher risk for developing cancer. So our limits are set such that we keep the risk consistent across the board of that 3% cancer, but the number itself, or the radiation dose, might be smaller for a younger female.
What challenges will crews face when they leave low Earth orbit?
With the exception of the Apollo astronauts, all crews have remained within low Earth orbit. And in low Earth orbit, the Earth's atmosphere and the magnetosphere is actually protected. And so the magnetic charge on the fields actually prevents some of the particles from getting in. So the composition of the environment will be the same types of particles. However, there will be more outside of low Earth orbit. So missions to the moon will result in much larger radiation exposures. Going to Mars, those mission durations will be quite long. And so not only will you have a higher radiation field, you'll also have a longer duration within that mission. And so you'll result in larger exposures.
One of the major challenges facing us is how to shield astronauts from radiation. Research tells us that some metals are good shields, but weight will be a major consideration. For example, in order to keep within weight limits, only thin skins could be applied to a craft, which will allow too much radiation into living quarters. But adding thick layers of radiation-blocking material could make the craft much too heavy. An added concern is, once the atoms inside the metal skin are hit by incoming particles, they would bounce around like billiard balls, causing secondary particle shedding, which could in fact be as dangerous to crews as the original radiation. One solution currently being discussed is the use of hydrogen-rich plastic such as polyethylene, which is the same material found in garbage bags. Hydrogen is a good radiation-blocking element, and some hydrogen-rich plastics can be formed into lightweight, strong shields that are about 10 times stronger than aluminum. This is just one of the innovative designs that are currently being reviewed for use in space.
The whole goal in the long run is to have our astronaut crews be as healthy as possible throughout the entire mission. Not just survive the mission, but be as healthy and thrive during the mission.